Hi all, in this video we will going to create simple chatbot with help of the land graph. Like I discussed in my previous video, first we will create the chatbot without memory, then later we will improve our chatbot with short-term memory, and later we will further improve our chatbot with the long-term memory. First we will run this application and we'll see how this works. First I will type hi, then we will wait for the reply. So you can see chatbot replied, how can I assist you today? Then I will type my name. My name is Alex. Then we'll wait for the reply. So you can see, nice to meet you, Alex. How can I assist you today? Then I will ask my name again. What is my... Yeah, you can see the chatbot couldn't able to figure it out my name because we don't have memory here. Here you can see we are not maintaining any conversation history, and also we haven't implemented any UI session here. It's calling the backend API and response as it is we are displaying here. Once we refresh this application, it will get clear all the conversation what we have now. I will show it to you. Let's refresh this application. You can see all the conversation got cleared because we haven't maintaining any memory here. Okay, first we will see the code, how we implemented this application with help of React and the backend Python with the FastAPI and the LangGraph framework. First we'll work through the code, later we'll introduce the memory here, then we'll see after introducing the memory how this application behave with the memory. We'll jump into the code. You can see here basically we have two application, one for the front end, other one for the back end. Front end will work to the front end code first. Here we have JSX. You can see we are loading the chat application. So this is the one we are loading in the app JSX. Here we have implement all the UI functionality here. So you can see you can work through this code. I will add my GitHub link in below description, so you can go through and see. And all the hook we have introduced here. This is where we implement the hook. Then here we can have the API calls. So all the backend API call we are having here. So you can work through the code, then you can understand how we implemented this. Then I will work too quickly to the backend application. First, this is the endpoints we are calling from the front end. You can see here chat endpoints we are calling from the front end. Then we have service class. From that service class we have a method. From that method we are calling the our LangGraph method. So here you can see this is the our LangGraph simple state graph application. You can see we have only one node like we discussed in my previous video. So same straight line LangGraph we are having here. You can see here this is the simple entry point and the edge. Then we compile it and we call this application, and we are getting all the input value from the our API. So first front end it's calling this endpoint, then we have a request message here. So you can see we have here Pydantic model. So here in we are currently having only one input value. This is a message. It's here we have added here. Once UI is calling this chat endpoint, it's calling the service method, then it's calling our LangGraph function. Then LangGraph function it will invoke with our graph, and it's calling our node. Here we are having the LLM call, then it will return us the response. That is how this simple chatbot work. Let's introduce memory, and we'll see after introducing memory how this chatbot work. Okay, now we will improve this application introducing the memory. We'll implement the memory here. First we need to have InMemorySaver. We'll import that InMemorySaver here. Then we need to have a checkpointer. Here we will add checkpointer, removing the existing one. Then we need to have thread ID, so we'll add thread ID. This thread ID need to pass from the UI, and also we need to introduce the configuration, so we'll add the thread ID in the service. Here you can see we have added the configuration with the thread ID. Then once we execute this application, it will get save the final state snapshot and will update according to the conversation. Let's say if we use same thread ID, it will get updated, and otherwise if we use different thread ID, it will create the new conversation. We'll show how this happen from the UI. Hope I think this here it's we have added all the necessary update. Let's see our service method. So we have thread ID, then we need to have in the schema thread ID here. So I think our backend application is ready now. We'll see whether it is running or not. Yeah. Now our backend application is, did you mean checkpoint, unexpected keyword argument, checkpointer save. Let's see what's the issue here. I think we have one issue. Let's go save unexpected memory chat API. Let's use the memory. Probably the issue is this, because we are not using the latest LangGraph framework, because argument checkpointer save. Let's see what's the issue here. In memory checkpointer save graph compile. Probably it should pretty much it. I think that's the only thing we have here. So it is wrong, right? It's checkpointer saver, not it is a should be the checkpoint. Okay, now now should be fine. Let's we will introduce a new method to retrieve all the thread IDs what we have in our memory, to introduce this function. Here we are calling the get all thread IDs. It will retrieve all the thread ID what we have in our memory. And also we need to have for particular thread ID related conversation, so we'll introduce that one too here. So we'll create a one other function in our chat application. It will help to get the relevant thread ID related conversation. Okay, we'll add those two here. Then we need to introduce this in the service class, so we have already there. Then we'll call this two method from our UI. I think, yeah, the backend is ready for now. So I think we have introduced all the backend changes. I think its backend is ready now. We'll see how we integrate this backend changes with the UI. We'll do the modification in UI application. We'll see what modification we need to do. We need thread ID, so we'll delete this one, so we don't need this further. we'll have it here. Use chat. Yeah, we have here all the thing. Here we'll have use chat hook here. Let's see what we have here. Chat application. So we need to have a thread. First, new chat. We'll see the new chat hook here. Here we need to have all the thread and the threads and the thread ID for 11 thread and all the threads we need to have here. And apart from that, we are okay with the messages and the new chat. We have new chat, and also we will show all the conversation what we have earlier. To show that, we need to add this navigation, so it will show all the conversation what we have earlier. Okay, now we need to see our hook. What we'll see the hook now. So we have threads here. We have added the threads. We'll see load threads. Initially it will call our conversation. It will load all the threads what we have in memory. Okay, it's fine. Then the thread ID. Okay, should be okay. Let's see our API call. Let now see our API call. This one we don't need further. Oh, we need this. We need this with the thread ID. We call this with the thread ID. Then it's, I think, should be fine now. I think we don't need this further. Yeah, this we don't need. Let's see. Send message. Let's see our hook. Send. Yeah, we have thread ID in trim. Okay, I think now our UI also now it's fine. We'll see the UI. We'll see any errors or no. I think now issue get fixed. We can run now. So we can ask same question what we asked earlier. Type hi. We'll see the response. You can see it's provide the how can I assist you today. And also you can see here we have current thread ID. It's mean our implementation is success. Now we have short-term memory in our chatbot. Then we can maintain our conversation history. We'll see. We'll ask same question what we asked earlier. My name is Alex. Okay, let's ask the question again. What is my name? Now this should be able to recall my name, and it should be able to provide the correct answer. We'll see. Yeah, you can see it's provide the your name is Alex. Now perfectly fine. Our application it's already have short-term memory. Let's start new conversation, and here we'll type hi. Then we'll ask what is capital of India. We'll see the response. Okay, you can see it's provide the capital of India is New Delhi. Then we will refresh our application. We'll see. So here you can see we have the both conversation what we had earlier. We'll check one by one. Here you can see we have our earlier conversation. So, and also we'll see the previous one also. Here you can see our previous conversation all we have here. Then we'll continue whatever we left off earlier. So I need to learn Java. Let's continue our conversation wherever we left off earlier. So here it provides a lot of guidance, and here then we'll go to the next. We'll switch to the next conversation, and we'll continue here. Then ask same question: what is the capital of Japan? Yeah, yeah, you can see we can have multiple conversation, and also we can switch each conversation one by one, and also we can refresh our application, and also it's we can see our conversation it's remain as it is. That is the power of having the memory in our application. But I will show you what are the issues we are having here. So we'll ask my name here. So in this chat history you can see I haven't provided my name, but in my previous chat history I already mentioned my name. Let's see this conversation, whether this conversation able to recall my previous conversation. Let's see. What is my name? See, it's provide I am sorry, but I don't know your name. Could you please tell me? It's mean this couldn't able to recall my previous conversation. It's mean even if we introduce short-term memory, it couldn't able to cross-check the. I mean, it couldn't able to cross-check the our previous conversation. It's mean this short-term memory only applicable for particular conversation. I mean, for particular thread. It shouldn't able to recall our all the conversation history. That's where we have issue in short-term memory. To overcome this one, we need to introduce the long-term memory. If we have a long-term memory, it should be able to go and recall our all the conversation, and will able to get the proper response. So like in our chat application, you can see in ChatGPT or other chat application, those application capable to recall all the conversation what we had earlier to get the provide the response. To improve this chat application like chatbot or other uh, professional AI chatbot, we should have long-term memory in our application. We'll see how we're going to introduce the long-term memory into this application. Before that, we'll check in ChatGPT how this works. We'll type my, we'll ask same question. My name is Alex. Then repeat the question. What is my name? It is provide that your name is Alex. We'll open new conversation and ask same question. That is my name. You can see it's provide that your name is Alex. Let's see introducing a long-term memory in our application, how it's behave. We'll jump into the code. We'll go to the backend first. We'll create the long-term memory application here. Here you can see we need to import InMemoryStore. So apart from the memory saver, we need to have InMemoryStore, and the check pointer we will add store InMemoryStore and the check pointer together. So that's how we need to introduce our long-term memory. Apart from that, in here we need to have a namespace with the user ID and the memories. We can have some other name also here, but definitely we need namespace to introduce the long-term memory. Here you can rename it to profile or something. You can have it like this. And apart from the thread ID, now we have user ID and the user ID with the namespace. Here we can have store, so it's search based on the namespace, and we can get the similar response. Here also we can check the similarity to improve our application, and based on the response we are checking the pacts what we had, what are the pact we have. Then uh, we'll provide the message to the LLM. Once we get the response, we'll store again into the in-memory store. Here you can see send message also we modify with the user ID. Here we have added the user ID to get all the thread. Here also we modified, we include user ID. It's load all the user ID related conversation, and also this is get conversation is same what we had earlier. These are the only changes we have added here. Others are as it is in our previous example. Okay, and apart from that we have to modify in our service class. So here service class we need to have user ID apart from the thread ID, and also get all thread IDs we need to pass the user ID. This user ID we are getting from the UI. So in the UI and schema also we have to change. We need to add the user ID here, and the API also we need to change. To get all the conversation we need to pass the user ID. Those are the thing we did. Those are the thing we did in the backend side, and let's see in the UI side what we need to do in React application. So we need to have user ID. We have added the new hook as a user ID. From there in the hook we will check whether are we having user ID. If it is not, first we need to define the user key. Then we'll check whether are we having this user ID in the local storage. If it is not, we will create one user ID. We'll set it up in the local storage. Always check the local storage. If it is not there, we will create the new user ID. And so only the change we have here for a user ID invoke change. So here we have added the user ID for to get the conversation, and also all the to retrieve all the conversation, and apart from send message also we invoke the user ID. Those are the changes we did in the UI side, and API call also we need to have those changes. Hope you have clear on this. Let's run our application. We'll see what's the response now we are having after introducing the long-term memory. Okay, it's for front end is running. We'll refresh and we'll see. We'll ask same question what we asked from the ChatGPT. Okay, we'll ask same question again. That is my name. Yeah, it's provided your name is Alex. Now we'll create new conversation and last same question. That is my name. Now you can see it's provided your name is Alex. Now you can clear this, right? So previously we had the issue. If even if we provide my name in within the one conversation, it couldn't able to recall in the new conversation to get the name. So now after introducing long-term memory, you can see it's capable to read the all the conversation what we have in our history, and it will provide the response like in the ChatGPT. Hope you have clear on this example. So in this example we cover without memory how how this chatbot work, and with the short-term memory how this chatbot work, and the long-term memory how it is work, and also we compare the ChatGPT and our chatbot application, you can see it's both are similar now. Okay, that's it in this video. Thanks all.